Let's move on to significant figures. This will tell us why was it important to understand accuracy and precision. Because significant figures, the number of significant figures talk about how accurate our value is. See, you can report the length of a pencil as 5 centimeters or 5.05 centimeters or 5.051238 centimeters. Okay, so the same pencil is measured and you get three values. If you use different devices having different precision, you'll get these different values. So if you use a scale or a common ruler, this is the measurement you'll get. If you use a vernier caliper, you'll get this value. Okay, if you use some more precise instrument, like which is really precise, which can measure up to 6 decimal places, you will get this result. The instruments which we are using, they tell us about the precision of the measurement. As an example, we considered, let's say we have a pencil and we measure the length of this pencil. We find it to be 5.50 centimeters. So how many significant figures are there? There are actually three significant figures here. This one, and this one. There are three significant figures. But if you report it like this, 5.5 centimeters, there are only two significant figures here. Although both the values are the same, but in the second case, there are only two significant figures, which tells us that we've used an instrument which is not really precise. We've used an instrument which can only report lengths up to 1 decimal place of a centimeter or up to 1 millimeters. Whereas the first instrument that we've used, the instrument which is reported 5.50 centimeters, this can measure up to 0.1 millimeters or 0.01 centimeters. So this device can measure things like 5.51, 5.56, 5.58. These measurements also are possible through this instrument. Whereas the second instrument, it can only measure things like 5.6, 5.7, 5.8, and so on. So if we get any measurement written anywhere, we should be able to figure out how accurate is that measurement. And that is given by significant figures. So there must be ways to find out how many significant figures are there in a given measurement, right? There are rules, and we're going to look at those rules now. So on the screen, you would see certain rules for deciding how many significant figures are there in a measurement. Now there are separate rules for decimal measurements and separate rule for whole number measurements. This you can find in any standard book. You can go through that. So what I've done here is I've just simplified the complicated part of it so that it's easier for us to remember all the rules. For decimals, if we have a measurement like this, 0.004004500, if we have a measurement like this, and the question is, count the number of significant figures here. So you should know that all zeros put in just for cosmetic purposes are not significant. So that's the first rule. That's the first simplification of the rule. Which zero here is put for the cosmetic purpose? It's this. Okay. 0 point something, you can just write it 0.5. This is as good as 0.5. These two are the same things. Okay. So this zero is for cosmetic purpose and we do not consider this to be significant. All right, let's move on to the right side. After the decimal point, we have a few more zeros. 1 0 here, 1 0 here. Until we encounter the first non-zero element, the first non-zero number, all the zeros preceding the first non-zero number would be counted as insignificant. So These are also insignificant. Why? Because these are used only to locate where the decimal point is. That is the only use of these zeros, to help us locate where the decimal point is. Okay. I mean, it doesn't tell us anything about the value, the actual measurement, these zeros, right? So that's why these are also insignificant. Next, once we encounter the first non-zero element or the first non-zero number, here it's 4. This is a significant digit. So it tells us something about the measurement. Then the zeros after the non-zero number, in fact, the zeros sandwiched between two non-zero elements would also be significant because 4005 is different from 405 and it's different from 45. These three measurements are different, and that is why even these zeros are appearing between two non-zero elements. They must be significant because this is different than this is different than this. Of course, we can see there is another 5 here. 5 is a non-zero element. It's going to be significant. It's a non-zero number. It is a significant digit. Then we have more zeros. Are these significant or insignificant? These zeros are also significant. Reason being very similar to this case, that 500 is not the same as 50. It's not the same as 5. So 500, these zeros have some meaning. These zeros have some meaning. So the zeros after the non-zero number have some meaning. They are also significant. So in fact, these zeros are also significant, significant, significant. In fact, the zeros lying between the two non-zero elements are also significant. So count the number of significant digits in this measurement then. How many significant digits do you find? 1, 2, 3, 4, 5, 6, 7. 7 significant figures. Why is counting significant figures necessary? Why are we doing this exercise? The reason is this. Any measurement can be reported in different units. The same length, 5.5 centimeters, can be reported in millimeters also, micrometers also, meters also, kilometers also. All these measurements, we have to ensure that the number of significant figures are the same. Okay, so whichever way, whichever unit we are representing it in, the number of significant figures which represents the accuracy should not change. So it helps us in properly writing measurements in scientific notation also. If we are changing units, the number of significant figures or the accuracy has to stay the same. So that's why significant figures are necessary. That's why counting significant figures are important.